So now we have found the components of HR, H5, Hz. So similarly, by equating the cylindrical coefficients, so we can find the ER, E5, Ez components. So once we find the ER, E5, Ez components, our ultimate aim is we need to find the components of ER and E5 and HR and H5. Since Z is the varying direction, where an R and phi are the constants, we are going to find the ER and E5 components, and likewise HR and H5 components. So to find the ER and E5 and HR and H5, so from the A equation, this is the A equation, so which we have already found HR. So from this we can find the HR, where HR is equal to minus 1 by j omega mu r into dou Ez by dou phi plus jr beta E5. So now we will take this value of HR and we will substitute in the E equation. In place of HR, we will substitute this corresponding value. So now substitute E equation 11 in E to get the E5 value. So now what happens, in place of HR, we have substituted the value of corresponding HR value. This 11th equation has been substituted over here. So it's given by minus dou Hz by dou R plus J beta into corresponding HR component called minus 1 by j omega mu r into dou Ez by dou phi plus jr beta E5 is equal to j omega epsilon E5. So after this, we will try to reduce this equation. So we are going to multiply this j beta inside this corresponding HR value. So it becomes j beta by j omega mu r into dou Z by dou phi plus jr beta into E5. So after this, we will try to segregate the components of E5 separately and the remaining components separately over here. So we have taken a corresponding E5 components to the right hand side. So it becomes j omega epsilon E5 minus the corresponding the j beta j omega mu has been multiplied towards the inside. So it becomes j minus j beta square E5 by omega mu. So now we can reduce this corresponding components. So we can j and E5 are common components. So we can take outside j and E5 is into omega epsilon minus beta square by omega mu. So this omega epsilon minus beta square by omega mu can be written as cross multiplied. Omega epsilon minus beta square by omega mu is equal to, we can cross multiply this one, so omega square mu epsilon minus beta square by omega mu. So now we will assume this corresponding components as a q. So q square by omega mu. So it is reduced as a, this whole component has been reduced as a j into E5 into q square by omega mu. So from once we find this value, so from this we can find the E5. So to find the E5, we will keep this E5 in left hand side and we will take all the remaining components to right hand side. So it's given by E5 is equal to omega mu by j square. So this omega mu goes upside and j square complete denominator, and then the remaining whole equation of your left hand side comes to the there. So minus dou Hz by dou r plus beta by omega mu r into dou Ez by dou phi. So after this, we will try to multiply this component into inside. So it becomes minus j by q square into minus omega mu dou Hz by dou r plus beta by r into dou Ez by dou phi. So since j is the denominator, to make it to the numerator becomes minus j. So this is the corresponding equation for E5. So E5 is given by j by q square into omega mu dou Hz by dou r minus beta by r into dou Ez by dou phi. So we have changed the corresponding signs inside. So to find this, likewise to find the ER, what we will do means from equation B, we will get the value of H5. H5 is given by 1 by j omega mu into dou Z by dou r plus j beta ER. So once we get the H5, we can substitute the H5 in the D equation. So where in the D equation, we can say here in terms of H5, we will put the corresponding B equation value over here and we can find the corresponding ER value. So you can see here, we can substitute the H5 in the D equation and then we can find the ER value. So in terms of H5, we have replaced the whole components over here and then we have multiplied the JR beta inside your H5 components. So it becomes JR beta by j omega mu dou Z by dou r plus j square r beta square ER by j omega mu is equal to j omega epsilon ER. So after this, once again as like that, we will segregate the components of ER into separate to the right hand side. So we will take this whole component to the right hand side. So j omega epsilon ER minus j beta square ER by omega mu. So after this, once again we will take the common components j into ER omega epsilon minus beta square by omega mu. So from this we can see here the omega epsilon minus beta square omega mu is given by q square by omega mu. So in terms of omega epsilon minus beta square omega mu, we will replace by q square by omega mu. So from this I can segregate the value of ER separately. ER is equal to minus j by q square. So here what happens, the omega mu by j into q square happens, and then to make the j into numerator we mix minus j by q square, and then we have multiply omega mu inside the corresponding left hand side. So omega mu by r into dou hz by dou phi plus beta into dou z by dou r. So this is your corresponding electric field component with respect to radius. So likewise we have find the ER and we have find the E phi. So now similarly likewise we can find the magnetic field components of HR and H phi. So these are the equations, and then so if you substitute the value of ER and E phi in C, and then we substitute the HR and H phi in F equations, so we will obtain this corresponding equation, dou square Ez by dou r square plus 1 by r dou z by dou r plus 1 by r square dou square Ez by dou phi square plus q square Ez is equal to 0. So if you see the 16th number equation, so all the components which we have, it depends on Ez. It's all the components that depends on Ez. So likewise, the 17th equation is all about Hz. So both are uncoupled. So that means that both to find the more solutions, the Ez is equal to 0 or Hz is equal to 0. So if Ez is equal to 0, then it is called TE mode. And then if the Hz is equal to 0, it is called TM mode. And to find to get the hybrid modes, both your Ez and Hz will be not equal to 0.